All right, let's suppose, I'm going to figure out this thing. Let's suppose we have 620 degrees, right? Something we can talk about. And I want to find two coterminal angles, okay, and then the reference angle. And this is over 360. The directions say theta is between negative 360 and 360. And what I'm looking for are two coterminal angles between negative 360 and 360. That's what I'm looking for. Well, this is not between those. Okay. So what do we do? Well, we know that one time around is 360, right? So let's subtract one time around. And do you agree that if I subtract 360 or add 360, it's going to be coterminal? Because it's going to go all the way around, land on the same spot, right? Okay. So we have 260 degrees. So 260 degrees is coterminal with 620, and that falls in our range here. Okay. Now I need a negative one. Remember what the book said. Add 360 or subtract 360. What do you think we're going to do? Subtract 360 from that. And I would get negative 100. Don't forget, put that degree sign. If you don't put the degree sign, it means something else. All right, it means that we're in radians. Okay? All right, so these two angles are coterminal. So we've done that. And both these angles are coterminal with the original one, 620. And they're also between these two angles, 260 and negative 100, are between my parameters here of negative 360 and positive 360. Okay, does that make sense? So if you're over 360 degrees, that's what you have to do. Keep subtracting 360 until you get one that's between these two intervals, and then you can find the other one. Madeline.
Remember, like, just double 360 and get whatever ready, because that's what I did on homework, but does that ever not work?
Oh, no, that'll work, but if you double 360...
It's like 720.
Yeah, I know, but you won't be within our range, but it is coterminal.
Okay.
All right, so now, what is the... What did you guys get for the reference angle? What would you get on this for the reference angle?
60.
80. Very good. 80. And so 80 degrees would be the reference angle. And you know, sometimes it's helpful, because this is what I have to do sometimes. Sometimes it's helpful just to draw a little bit of a sketch here and look at 260 degrees. Well, I know from here to here is 90, 180. To the other one here is 270. That's 270. I want 260. So really what we want is this angle right there, which is 80 degrees. Okay? It's just one way to look at it. That's what I have to do sometimes. Right? So your reference angle is 80 degrees. And that tells me that, you know, the tangent of 260 and 80 are the same, and, you know, we can do some different things when we're solving angles and triangles. Okay, so let's go over, and this is all part of 8.2. Okay, so let's go over some homework problems. Okay, let's be specific. Let's take the problems between... Did you have any trouble 9 through 12 to sketch those angles? Okay. How about from 13 through 36? Yeah, Rach.
Well, for mine, like, there was a couple ones, but, like, 29, and the ones that did have the solution that was higher than 360,
Right.
I got the right answers, but I always switched the signs, like which one was negative and which one was positive, and I don't know why. Like
Okay.
every time I checked it, it was switched.
Well, let's think about this. Let's take 410 degrees. And let's think about that. 410 degrees. Let's see where that's at. Once around 360, and then we have to go 50 more. So it's going to be somewhere in here, right? And so 50 degrees, and that would be 1. And then if you subtract 360 from that, you'll get negative 310.
That was number 29.
Yeah, it was 29. And so these two angles here now are within our range of negative 360 and 360. Okay, does that make sense? Okay. Anything else between 13 and 36? I think I answered everything that was over 360, positive way or negative way. Okay. How about problems 37 through 47? 43? Right. And I want to do one of those problems. Find the exact values of the 6 trig functions of theta given each point in the terminal side of theta and standard position. All right, this is problem number 43 and 841. Negative 4 and 6. Negative 4 and 6. And I think it's helpful negative 4 and 6. Okay, so that's that point right there. We're going to strike a ray through that point. We want the 6 trig functions. Now this ray has rotated this way, hasn't it? And if you recall, that's a positive rotation. Going counterclockwise, positive rotation. We're looking at, that's your theta. And the reason why we want to use that as your theta is because the reference angle, and we know that this angle starting from the x-axis to here, trig functions are the same as the reference angle. There's our right triangle. Okay. And we have a point up here of negative 4 and 6. The distance, the height there is 6, and the distance of the base of this triangle, we're going to write that as, and I know it's 4 for the distance, but we're going to write negative 4 because I need that value. Sine, cosine, tangent. Don't forget those 3. Then it's simply reciprocals. Cosecant, always in this order. And as we talked about yesterday, in this triangle here, opposite, which is your y value, over hypotenuse, which we call r. Right? Rotate this all the way around. That r stands for radius. Okay? So the y value for sine would be 6 over r. So now I have to use the Pythagorean theorem to find that distance from the origin to that point. And my x value is negative 4. Y value is 6. 16 plus 36 is 52. So r is equal to, always positive, square root of 52, which I can write as 4 times 13, which is 2 square root of 13. Two square root of 13. 2 and the 6 can reduce, can it? Okay? 2 and the 6 can reduce to 3 over the square root of 13. I'm going to leave it like that for now. Cosine is the x value. Let me rewrite that. As 3 over the square root of 13. And that's what sine is. Cosine is the x value over the r. And the x value is -4 over 2 square root of 13, which comes out to be -2 when you reduce the 2 and -4 over square root of 13. Tangent, here's a trick, tangent. Didn't we find out that tangent was sine over cosine? Sine over cosine. Positive over a negative is negative. It's the y over the x. It's the y over the x. -3 over 2. Now I have the reciprocals, which is r over y, which is square root of 13 over 3. Secant, which is r over x, would be negative square root of 13 over 2. And the cotangent, which is a reciprocal of tangent, is -2/3. Okay. What quadrant are we in? Second. If you look at my trig functions, sine and cosecant are positive. All the others are negative. All right, that was problem 43. That's how you do all those problems from 37 to 47. 48 through 55. That's where we had some trouble on that. No? All right, let me read the answer here. Well, you guys had the answer. So let's take, does anyone want to see any of those problems? Which one, Alex?
From 49 through 55.
Yeah.
I don't know how to do them, so.
Okay. All right. Ryan, what about you? Which one?
Honestly, any of them, I don't even know how to start that one.
All right. Let's try 49. They give you certain information. 49 says we are in quadrant 3. And we know in quadrant 3, because you guys have memorized this, the tangent and cotangent are positive. All others are negative. We need to know that information. Then they give you the information that cosine of theta is -1/2. I know it's negative. What is cosine, Ryan?
For the adjacent over
Yeah, but go in terms of
y over r.
x over r.
Over r.
Yeah. And so we have our x value and our r value. Our x value is -1 over the radius, which is 2. So if we use this, okay, my r is 2, my x is -1. I want to find the y value because I know that sine of theta is y over r. So sine of theta is going to be y over r. There's my r. I know it's going to be negative because I'm in the third quadrant. Okay? And so let's solve this. 1 squared, -1 squared is 1. 4 minus 1 is 3. Y squared equals 3. y equals root 3. Plus or minus, it's going to be minus. And why is it going to be minus? Because I am in the third quadrant. Okay. Did you have a question?
Kind of. Yeah.
Go ahead.
Well, I just was wondering, how do you know that the 1 is the negative 1 and not the 2? Not that
Because-
it matters if when you're
good
finding
question.
it out, but for sine it does.
Good question. How do you know the 2 is not negative? Because I do know that cosine is x over r. And I know that r, which is my radius of the circle, which is my distance to that point, is always positive. Radius r is always positive. Okay. Well, now that I've got sine and cosine, the rest should be easy. Tangent. It's the y over the x. So it's going to be a negative over negative is a positive. Square root of 3 over 1 is square root of 3. And now I have the reciprocals. Negative 2 over root 3. Secant. Negative 2. Cotangent. 1 over square root of 3, which is square root of 3 over 3.
We only have to find the tangent though.
Oh, do you?
Yeah.
Oh, I thought it said find all 6 trig functions. Yeah. All right, so if you just have to find tangent, once you find sine and cosine, once you get this information, you know that tangent's positive because we're in a third quadrant, and it's simply it's the x value, or it's the y value. You got to find that y value over the x, sine over cosine. Does that make sense? Right? Okay. Cosine and secant. It's on the bottom of page 839. Page 839 on the bottom right. Every day we use that information. Okay. Any other questions on this lesson? Anything at all?